Castle or their or his affiliates are not responsible for followers' use of the information provided here.
Hi everyone, Stephen Van Tassel here, wildlife control consultant, bringing another episode of Living the Wildlife as part of the Pest Geek podcast family. Hope your week went well, as I always ask you. I hope things are going well for you. I'm still in the midst of my busy season. I have a ton of training to provide here in terms of my day job, and so I am been under the gun with the amount of traveling I've been doing and the amount of work. You have to keep tweaking those PowerPoints and that sort of thing. So a lot of work trying to make sure things get better and better and better. Do take a few moments let me go back. Glad to have you on board. I do hope you take a few moments and subscribe to the channel, ring the bell, and give us a 5-star review. Do join us on Facebook with the Pest Geek Podcast family, where you can tout your achievements and your trials and even ask questions and join the revolution, as Franklin calls it. You can reach me at wildlifecontrolconsultant@gmail.com, wildlifecontrolconsultant@gmail.com. I'd love to hear your thoughts about different shows that you would like to have, different topics. Perhaps if you have a product or service that you would like to spotlight, we love doing interviews. We believe very strongly in getting new information out to the wildlife control community. So definitely reach out to me again. That is wildlifecontrolconsultant@gmail.com, wildlifecontrolconsultant@gmail.com. Well, looking at some, I was trying to think about what my topic would be for today. And I've been doing some work in rodenticides, and so I figured, well, let me look at some of the literature that I have. And I came across this article about vitamin K. So let me kind of pull up my PowerPoint here for you, and to see how that I would want to ask this particular question. And you probably had this question on your own and maybe just didn't formulate it well, because you probably, if you've been in the wildlife control field and doing rodenticides, certainly those of you who are pest control operators who also like to dabble in some vertebrate pest work, you should already be very familiar with this, and I would assume that you would be. And that is, we all know that what's the antidote for anticoagulant poisoning? And the answer is vitamin K1. Okay, because there's different kinds of vitamin K. We'll talk about that shortly. But vitamin K for short, that animals exposed to anticoagulants need to get high doses of vitamin K in order to counteract the effects of anticoagulants in their system. Now, I'm not going to get into all the chemistry. I'm not sure I could explain it as well as it should be explained, but it's complicated in terms of how the anticoagulants interfere with our clotting production. It does some things in our liver and what have you. But anyways, it's how animals die that consume anticoagulants. It causes them to bleed. Vitamin K helps counteract those effects to break that chemical change that occurs in our system. So the question becomes, especially when you have reports of people saying, my anticoagulants are not killing the rodents the way I would like. Is it possible that it's not really resistance in the sense that there's a genetic change in the animal that makes it resistant to anticoagulants, but is it that there's food available that the animal is eating that's helping to reduce the efficacy of anticoagulants? Now, let's just say if your rodent was eating dog food, maybe your client was feeding the dog outside. Dog food is going to be fortified with vitamin K, so your rodent is consuming some of your anticoagulant bait, but he's also consuming some of that dog food. And is that reducing the efficacy of the anticoagulant among that rodent population? That's the question. So let me to repeat it for those of you that aren't able to view this because perhaps you're driving. It's could foods rich in vitamin K reduce the efficacy of anticoagulant rodenticides? And we'll just say on rodents. Okay. And that's the question. Well, before we get there, let's take a look at what some of the different types of vitamin K there are. There are essentially 3 different kinds of vitamin K that we're going to be interested in. The first one, of course, is vitamin K1, and its scientific name is going to be phylloquinone or phytomenadione. And it's a vitamin produced by deep green plants. You know, your mother was always telling you, eat your spinach. You know, that is a food rich in vitamin K. This vitamin K2 or K2 is the menaquinones, and it's produced in the digestive system from the microbacteria that are going to be in our gut. And it's believed to play only a small role in our vitamin K needs. Now, I'm saying we because anticoagulants, of course, can harm humans, but these would also occur in the gut of the various rodents as well. But it doesn't seem that vitamin K2 really plays a significant role in helping the vitamin K needs of either the rodent or us. Vitamin K3 is known as menaquinone, and it's a synthetic compound, a chemical compound that is, but our liver enzymes convert that over to menaquinone, which of course is vitamin K2. So the real player here is vitamin K1. Okay, that's the real player, and again, it has a role, as you all know, as an antidote to the effects of anticoagulants. And so if you're, let's say, a dog consumed a whole bunch of anticoagulants, the veterinarian would have to monitor that dog and give it high doses of vitamin K over an extended period of time, depending on whether it was a first-generation anticoagulant rodenticide or a second-generation anticoagulant rodenticide. If it's a second-gen, the dog is going to be getting vitamin K for a very long time because second gens have an extraordinarily long half-life, and it takes a long time to work for the animal to work that through their system and get that anticoagulant out of them. But that's a topic for another presentation. The bottom line is we in the animal kingdom need vitamin K to survive. And whether we require a constant supply of vitamin K, so either we use it or we lose it. If we use it, then it's fine. But if we have too much, we excrete it. It's not something that we can sort of store. It's not like a fat compound vitamin that we can kind of build high levels of it up or something in our system. It's either you have it, and if you don't, when you need it, if you don't have it, you're not, you have to get it from outside of ourselves, and you can't store it. So it's not like you can have a lot of vitamin K today, and a week later that's going to hold you, for a week later or something like that. So animals need to be constantly refreshing, which is fine because animals, just like we do, are eating all the time. So what are some of the plants that are high in vitamin K1? And here they are. Here are some of them: collard greens, Brussels sprouts, spinach, sugar beet greens, and the common dandelion. And I have some figures here for you in terms of how much vitamin K there are per 100 grams of the food. So, and we're talking about very small amounts here. I mean, 0.62 milligrams of K1 for every 100 grams of collard greens, 0.19 milligrams of K1 for every 100 grams of Brussels sprouts, 0.54 milligrams of K1 for every 100 grams of spinach, and then 0.48 milligrams of K1 for every 100 grams of sugar beet greens. So we're not talking about huge quantities here. I mean, vitamins we only need small amounts of them, but we need them on a regular basis. And again, vitamin K1 does counteract the effects of anticoagulant rodenticides. So the question is, if a rodent is feeding on your rodenticide, your anticoagulant rodenticide, and vitamin K rich foods, does that reduce the efficacy? And, instead of getting 90% kill, are you getting, 70% kill? That's a pretty significant issue when you're dealing with certain clients. What are some foods that are low in vitamin K? Well, carrots, they have only 0.01 milligrams of K1 for every 100 grams. Potatoes, same amount, 0.01 milligrams of K1 for every 100 grams. And then apples are even less, and that's 0.002 milligrams of K1 for every 100 grams. So orders of magnitude less vitamin K in apples than compared to potatoes and carrots. Of course, potatoes and carrots are significantly lower, orders of magnitude lower than, things like spinach. So the researchers looked at Montane voles. Now, Montane voles are one of the microbacteria species in the United States. I put up a range map. Montane voles, of course, as you know, montane means mountain, and so it's in the far west United States. Montane voles occur in Montana, in Wyoming, in Idaho, in Washington, and Oregon, Nevada. Looks like Colorado, Utah, and California, and then there's some isolated groups down in Arizona and New Mexico. And it is a vole that does attack agricultural crops. Now, so understand the study was done specifically on this particular vole. Okay, so make sure we can't always, take this information and apply it to other species of voles, although it wouldn't necessarily, not like it's a crime to do so. It just means that understand this research was done specifically with the montane vole. That's Microtus montanus. Okay, so that's important to recognize. And what they basically did was they fed the voles basically the foods that were rich in vitamin K, and then, for a period of time. And then they gave the voles like a choice test to eat the rodenticide or the foods rich in vitamin K1. And then found out, how long does it take them, do they die? And interestingly enough, voles that were treated with chlorphacinone, you may know it by the brand name of Rosol, they all died 100%. Whereas the voles that were fed diphacinone, only about 70%, if memory serves, died. So then they did another study, and they said, all right, well, let's find out if diphacinone will work better if the voles don't have access to the vitamin K rich foods. And the mortality went up to 80%. So it does appear, and again, they were very tentative in how they were phrasing this, but it does appear that diphacinone isn't as effective on montane voles. And it seems, although they want more research, of course, to really clarify this, that it appears that when montane voles have access to vitamin K rich foods, the efficacy of diphacinone gets even lower. But they didn't say that was certain because they wanted to do some additional research tests. So what they suggested was that chlorphacinone was the product that you would want to use if you're trying to kill montane voles. And, perhaps those of us in the field, if, you may want to be thinking about if you have the choice, if you're using diphacinone products on voles and you're getting good success, well, then stick with it. there's no reason to change other than just make sure you should be changing it every couple of years, your active ingredient anyways. But if you've been using difascinone on voles and you're not that happy about the success, then maybe you want to transition over to a chlorofascinone product and see if you get a little better control using chlorofascinone. Or transition over to a non-anticoagulant like a zinc phosphide. But it's something to keep in mind. Now, some of you may be thinking, well, what about the formulation of the product? Was that involved? Well, it turns out that there was no difference in terms of consumption. That voles that were eating the difascinone product were eating as much of the difascinone product as other voles were eating the chlorofascinone product. So the consumption rates were about the same. In fact, they actually ate more of the difascinone product, but the authors said that was an artifact of the fact that those voles weren't getting sick as quickly as those who were eating the chlorofascinone product, which makes sense. But so it wasn't a consumption problem, because clearly if the animals are not eating the bait, well then obviously the anticoagulant's not going to work, right? I mean, there has to be a certain amount of consumption to get a toxic dose, right? So it's a fair question, but just understand that the researchers in this particular study accounted for all that. So the research article, if you want to look it up yourself, let me just read you the title, read you the authors and title here. It is Whitmer, Snow, and Moulton, the 2013, and the title of the article is The Effects of Vitamin K1 Rich Plant Foods on the Efficacy of Anticoagulant Rodenticides, Chlorofascinone, and Difascinone used against Montane Voles, Microtus montanus. International Journal of Pest Management, Volume 59, Issue 3, pages 205 to 210. Now let me read that title for you again for those of you that may not have caught it. The Effects of Vitamin K1 Rich Plant Foods on the Efficacy of the Anticoagulant Rodenticides, Chlorofascinone, and Difascinone used against Montane Voles, Microtus montanus, published in the International Journal of Pest Management, Volume 59, Issue 3, pages 205 to 210. So I hope that's going to be somewhat helpful for you. And let me just get down to this, definitely think about what is the active ingredient you're using when you're controlling voles, and are you getting good success? And perhaps if you're not, you want to be thinking about maybe you want to move over to a chlorofascinone product and see if that can give you a little bit better control. But the bottom line was, I didn't give you what their bottom line was. And the bottom line was, as far as chlorofascinone is concerned, the authors found no indication that vitamin K rich foods had any impact on the efficacy of chlorofascinone on Montane voles. And they suggested that people continue to use that if they're trying to control Montane voles. In other words, what else they were eating didn't matter. And so what's interesting is they also did some other research on other animals, such as the brown rat and the roof rat, to see if vitamin K rich foods had an impact on the efficacy of anticoagulants on those animals. And that'll be a topic for a future podcast. Well, I hope you found that helpful today. It's important for us, again, in part of the Pest Geek podcast family, that we do get geeky, and it's important to really understand the products that you're using. And this is why record keeping, it's not just simply a legal requirement that you have to do for the use of these products on other people's ground, which is important in and of its own right. But I do hope you take the time to reflect on the data that you're collecting and asking yourself the deeper questions. Am I getting good take-up, and am I getting good control? both of those questions need to be answered because you need to be monitoring whether you're starting to see resistance, whether you're seeing resistance, whether it's behavioral resistance or actual rodenticide resistance. So those are important things. And so we want to be sure that these are dangerous products, and we don't want to be using products that aren't working. If they're not working, then we don't want to have them out in the environment because they're still going to be deadly to animals that don't have any resistance to these products. So it's important for us to keep that in mind. And you may have those questions about what is the effect of vitamin K rich foods on the efficacy of my anticoagulant. So as far as chlorphacinone is concerned, when it deals with Microtus montanus, the Montane Vole, it doesn't have any impact at all. But time will tell whether that's the case for other species of voles, or whether that fact holds true or not with other species. Well, I'm Stephen Van Tassler. You've been listening to Living the Wildlife as part of the Pest Geek podcast family. Do hope you take a few moments to subscribe to the channel. I do publish on Rumble. Would love to have you over there if you want to get things faster. I doubt you can download them very quickly from my Rumble account. Just go to Wildlife Control Consultant over at Rumble. Otherwise, they're going to be here on YouTube as part of the Pest Geek podcast family. If you have questions, comments, yes, even criticisms, you can reach me at wildlifecontrolconsultant@gmail.com. That's wildlifecontrolconsultant@gmail.com. Would love to hear from you. Again, living the wildlife. Why do we call it living the wildlife? Well, because we want you to live the wildlife, not be the wildlife. Take care, everyone.